Hello, when it comes to projectile motion, for some reason we are obsessed with these two things. The maximum height reached and the horizontal range. That means how far away does it land. So in this video, I'm going to show you how to calculate these two quantities. A reminder, the key to solving projectile motion is to split the motion into a vertical motion and a horizontal motion. So the vertical motion is a constant acceleration motion. The horizontal motion is a constant speed motion. If you combine these two, you get projectile motion. So a projectile motion is just a vertical throw that's also moving forward at a constant speed at the same time. Yeah? So a projectile motion is a vertical throw that moves forward at a constant speed. Just remember that. Okay, so given a projectile motion that was launched with speed u at angle theta above the horizontal, what is the maximum height reached? So, the key is to realize that the vertical component of velocity at the maximum point is 0. Yeah? Because if your vertical velocity is positive, that means you're still on your way up. If your vertical velocity is negative, that means you're still on the way. That means you are already on the way down. So the instant when your vertical velocity is 0 is the instant where you're at the very top. So if we use the v squared equals u squared plus 2as equation onto the projectile motion, we get the maximum height straight away. Yeah. So we purposely put the vertical velocity to be 0 so that the vertical displacement is the maximum height that we are looking for. Then be careful, if you are using the upwards is positive convention, then A, you got to sub in with negative G. Okay, what about the horizontal range? This one cannot be done in one step, yeah? So a few things first. Firstly, let's call the time when it lands TF, time of flight, yeah? TF, time of flight. And the time when it reaches the peak, let's call it TP, time to reach the peak. Because of the symmetry, TF is actually just twice of TP. So how would you find TP? Again, we make use of the fact that the vertical velocity is 0 when it's at the peak. Then you use v equals u plus at. So again, we're dealing with the vertical motion. So we purposely put 0 here. Vertical velocity is 0. So that the time will be the time to reach the peak. So from here, the time to reach the peak is just ui divided by g. Which means the time of flight is 2 times of ui divided by g. Now to calculate the horizontal range is really easy. Because if it spends this much time in the air before it lands, then how far has it moved forward? The horizontal motion is a constant speed motion. So it's just speed times time. Yeah? Distance is equal to speed times time. This is just PSLE math. So this is the formula for the horizontal range. Okay, it's probably helpful to have a numerical example. So let's use this example again. Alright, so we have a cannonball launched at initial speed of 120 meters per second at an angle 25 degrees above the horizontal. So we are going to calculate the maximum height and the horizontal range. First thing is always to resolve the initial velocity into its horizontal and vertical components, which are these two numbers here. So how do we obtain the maximum height? Use the fact that the vertical velocity is 0 when it's at the top. Yeah? So use the v squared equals u squared plus 2as formula. So we are working on the vertical motion. Yeah? So all the v's and the u's and the a's and the as are all vertical components. So we purposely put the vertical velocity to be 0 so that the vertical displacement will correspond to the maximum height that we're trying to solve. Ui, make sure you're putting in the vertical components, yeah? Don't make the mistake of putting in 120 meters per second. And the acceleration is a negative 9.81 because we are using upward to be positive. So ta-da, you get the maximum height, just like this. It's so easy, huh? Now the horizontal range, which involves a few steps. So first step, find how long it takes for the projectile to reach the peak, which is just this number here. Actually, it's very obvious if you think about it. So your vertical velocity starts off as 50.71, and every second is reducing by 9.81 meter per second. So how long does it take for 50.71 to drop to 0? It's just 50.71 divided by 9.81, isn't it? So by hook or by crook, yep, you got the time to reach the peak. So what is the horizontal range then? Remember, the horizontal motion is a constant speed motion. Yeah? The projectile motion is just a vertical throw that's also moving forward at a constant speed of, in this question, 108.8 meter per second. Yeah? So just do distance equals to speed times time. So speed is the horizontal velocity. The time is twice the time it takes to reach the peak. Yeah? So this is the flight time essentially. There it is, you get the answer. Easy, huh? Okay, ta-ta!